5.2 Check your understanding. A skydiver opens his parachute and shortly thereafter, he is moving at constant velocity. A. What forces are acting on him? B. Which force is higher? A. What forces are acting on him? His weight acts downward and the force of air resistance with the parachute acts upward. B. Which force is higher? It's neither the forces are equal in magnitude. 5.4 Check your understanding. A 550 kilogram sports car collides with a 2,200 kilogram truck, and during the collision, the next force on each vehicle is the force exerted by the other. If the magnitude of the truck's acceleration is 10 meters per second squared, what is the magnitude of the sports car's acceleration? So, given 550 kilogram car, 2,200 kilogram truck, and the acceleration equals 10 meter per second square of truck. Therefore, we derive to the formula F net equals ma. But the question is the car's acceleration, so we will derive to the formula acceleration equals F net over m. So, equals to 2,200 kilogram meter per second divided by 550 kilogram is equal to 40 meter per second square. Therefore, there are 40 meter per second square magnitude of the sports car's acceleration. Check your understanding 5.5. A car has forces acting on it. As shown below, the mass of the car is 1,000 kg. The road is slick, so friction can be ignored. A. What is the net force on the car? B. What is the acceleration of the car? A. What is the net force of the car? Given is F1 equals 450 Newton 30 degrees and F2 is equal to 350 Newton 10 degrees. Solve for x direction. So therefore, we will derive to the formula Fx equals F1 sine 30 degrees minus F2 sine 10 degrees is equal to 450 sine 30 minus 380 sine 10 is equal to 159.01 Newton. Second, solve for y cos direction. So we will derive to the formula Fy equals F1 cos 30 degrees plus F2 cos 10 degrees is equal to 450 cos 30 degrees plus 380 cos 10 degrees. Therefore, the Fy is equal to 763.9 Newton. B. Formula A is equal to F net over m. So given a magnitude is equal to 1,000 kilogram, Fx is 159.01 Newton, Fy is equal to 763.9 Newton. So first step is to find the x component, which is a sub x equal to 159.01 n divided by 1,000 kilogram is equal to 0.159 meter per second square. For y component, a sub y is equal to 763.9 Newton divided by 1,000 kilogram is equal to 0.7639 meter per second square. 51. Problem solving. What net external force is exerted? A 1,100 kilogram artillery shed fired from a battleship if the shell is accelerated at 2.40 times 10 to the power of 4 meter per second square. So given m equals 1,100 kilogram and the acceleration is equal to 2.40 times 10 to the power of 4 meter per second square. So we will derive to the formula F net equals ma is equal to 1,100 kilogram times 2.40 times 10 to the power of 4 meter per second square is equal to 26,400,000 Newton, or 2.64 times 10 to the power of 7 Newton. B. What is the magnitude of the force exerted on the ship by the artillery shell, and why? The force exerted on the ship is also 2.64 times 10 to the power of 7 Newton because it is opposite the shell's direction of motion.